So Project David is our attempt to create a gesture-based learning environment. What do we mean when we say gesture-based? Gesture-based is anything that you use today, such as a smartphone, your iPad, your Android device. Pretty much when you're doing functions like you're pinching or you're swiping or you're zooming into an image on your phone or your device, that's what we're talking about when we say gesture-based. So for our project, what we've decided to do is take a three-dimensional model of an ancient Greek treasury. Then we interface that with Microsoft Kinect. We felt that the Kinect was actually the best decision as far as hardware went.
So the hardware we ended up selecting was the Microsoft Kinect. There were three primary reasons why we picked it. The first one being it's super popular. There are so many people out there that are using it and trying to figure out what they can really do with it. The second one being it was relatively cheap and easy to get. And then the last one is it's open sourced. So the libraries that are available are immense. So when coding, when we had to start coding for the game, it became very easy to get our hands on.
Why? Why did you do this project? Well, the short answer is disengagement with traditional scholarship. And what that really means is there's a disconnect that we felt with things like just a book or maybe a slide that you see or this PowerPoint presentation. And it's not to say that these things aren't good. They definitely have their value. But today's students are changing. We're so involved with digital media and we have such high expectations that we felt that there could be a better way for us to learn. When we walked into the Ashes to Art class the first day, we were given these excavation reports. I specifically was given the excavation report for the Cyrene Treasury, which was done by Jean Basquiat and Yuri Fourmin in 1952. The problem is they were very complex. I mean, you look at some of these drawings and you want to be able to turn it, but you can't because it's only drawn from a couple of different angles. There's only so much they were able to do at that time. Now, when I took those drawings into Google SketchUp and I started making them, I was having a dilemma. I needed to figure out how, specifically how the gutter was arranged. I couldn't get up in the gutter because it doesn't exist anymore. I mean, today these are just ruins. They're nothing. They're just blocks that are sitting there. When I started to research and look at other people's models to get an example, which is what you normally do within academics, I couldn't find source material. I mean, you go out there and you see some beautiful model and you say, hey, that's fantastic. How did you do it? There really is nobody that's going to tell you exactly, well, I went to this book, I had this source. So we needed to figure a way how to bridge this gap, but also to make it interesting at the same time. So what we wanted to do was give somebody that appeal that they would have when going through a game. We didn't want to make it that much of a gaming environment, but we wanted to give it somewhat of that feel. But then we thought we should also cross it with a design environment. What I mean by that is a design environment is that you're able to do things like grab a block and make it bigger or make it smaller, or actually go up to the top of the roof and see exactly how that architecture is built. We also wanted to make it legitimate for academics. This could be something that you could really use as a source material, whether you're in elementary school or you're in high school or you're a college graduate. It would be open for all people to use, but it gave you a very interesting way of interacting with it. You moved, you talked to it. We felt that if we put all of these capabilities together, we'd create a platform that not only was interesting, but was very useful.
So this database can have any number of media built into it. For example, we can upload the books that we used for citations for a user to go ahead and look up as they're interacting with the environment. Or it could be pictures taken from the actual site at Delphi. Another could be videos that were taken, panoramas. Any assortment of media can be uploaded and utilized when you're interacting inside of the environment.
So what we wanted to do was create a platform which would have the best of both worlds. We wanted it to be that you could physically move and interact with it, but at the same time you could also speak to it and it would really respond to you and basically do the things that you normally would have done, but you're using your hands instead of being tied to a mouse or to a keyboard.
So after we figured out what kind of hardware we were going to use with the Kinect, we had to figure out just how it worked. And here is the Kinect that we actually use in our gaming platform. If you take a look, there's 3 different cameras that are built onto the Kinect itself. The first one in the middle is the regular webcam that you would see on something like your laptop. And this looks at the 3 different channels of RGB, which is the red, blue, and the green channels. And it just looks at everything like you would with your laptop. Then from there, there's an infrared and then there's a depth camera, and both of those work in conjunction together. Now the infrared camera sends out thousands of little dots all over the room that the person can't usually see, but it scans the environment and looks at all the objects in that area and allows the interaction to take place. And then the depth camera, which scans the room to see where objects are in relation to space and then places those objects in the gaming platform.
Our process begins with a 3D virtual reconstruction of the Greek treasury of the Cyrenes at Delphi. In order to do this, I had to learn how to use Google SketchUp. Google SketchUp is an incredibly easy program for the novice. I came to find out, however, that the first models that I had built weren't incredibly detailed and weren't very useful. At this point, I decided to implement my own method, which I've termed the bricklayer approach. It's not necessarily anything that's incredibly new, but it's very detailed. In modeling every block, we allow the Treasury to be very versatile for many different uses. As far as you can go into digital printing with it, you can use it for PowerPoint presentations to get all kinds of unique views, or for our case, with the Microsoft Kinect, we are able to actually embed metadata into all the different pieces of the Treasury. The design of the user interface. What this really entails is the entire visual look of the game, all the aesthetics, everything down from a little graphic to a little bit of text to what kind of pictures are used and how is this all really arranged and organized. Well, here it's a little bit odd because you're dealing with people's movements and their actions, so what I might initially think looks really good actually starts to change as soon as the person starts to interact with it, because now we have to account for, well, how long is somebody's arms? What is really the most comfortable thing to do as opposed to what visually makes the most sense for you. Normally you can design something really quick and then have a person just go ahead and do it. With our system, you design it, then you have to get a whole group of people together, then you have to take the results from that, and then you make changes. So the process is a little more laborious, and then from a design aspect, not everything goes exactly the way that you want it to go. Certain buttons need to be larger, certain elements need to be changed to really fit the gestures and the movements as opposed to what visually that we're always taught looks the best. So where do we go from here? Well, for one, more user testing. Any great system benefits from user testing. Beyond that, expansion of models. The more models that we actually have, the more valuable our system is. The next thing that we are looking at are different hardware and software applications. Now, 2 different products that are coming out this year, which are of great interest to us, are the Leap Motion and the Google Glass. Google Glass uses augmented reality to engage viewers. We easily could see our system integrated into Google Glass. Leap Motion is a little bit different. Leap Motion is actually a desktop sensor, which recognizes the viewer's fingertips, facial gestures. It works really well at close range and just fits right on top of your desktop. The most obvious thing is that we need more user testing, preferably in a classroom setting because that's really the intended use. Beyond that, an expansion of the models built actually in Delphi. The more models that we have, the more metadata that we can incorporate into it, the more rich of an environment that we can give to the user.